Welcome, ladies and gentlemen, to our mini unit, a mini, not a many, but a mini unit on transformations. So we're going to take a look at different transformations, and the first one we're going to take a look at is translations. So we're going to take a look at these translations and what they are. So we're going to identify and use translations. So let's take a look at the vocabulary there. The first word, and I'm going a little bit out of order, I want to define for you what a transformation is. It's an operation that maps, or another word for mapping is to move an object or move a figure to a new image. And so we still have this image. It's going to hold its shape. It's not going to change shape for this, but it's going to move along here. So now we have what a translation is. A translation is a transformation, so we're talking about these transformations, that slides a figure the same distance in the same direction, no turning. So our figure could be, for example, if you look at the bottom of the page, a car. And so we're going to slide that car. It's going to keep the same direction, and all the wheels are going to travel the same distance. It could be a line segment, and so what that means is each endpoint of that line segment is going to travel the same distance in the same direction. And so now we have this word image, and the image is just the new figure that you get after any transformation, and it has a special notation. We're going to use, let's say, Q. Q is our original. So if this was our original point Q, Q, a little bit neater, Q prime is what we would call our image. Okay, so the image is just the new one, and we have it with that apostrophe, we call it prime. All right, so example one, we're trying to figure out if a figure and its image are an example of a translation. So guys, to make sure you're there, this is page 75. So decide whether the gray figure is a translation of the black figure. And so when we look at A is a translation. So we're going to say it is a translation because the orientation is just a fancy word for direction. Okay, the direction that that truck is facing did not change. So remember, it's just this slide. It's like a little baby pushing that truck around. It didn't turn it, it just slid it across the floor. If we look at B, B is not a translation because the orientation has changed. Okay, the image, this gray car, is what we call a reflection. Think of looking in the mirror, it's the opposite of it. They fold in half. And then C is not a translation because the orientation, once again, has changed. It's not facing the direction. And so this is what we would call a rotation. We took this and we spun this figure in, we turned it in a 90-degree angle. So we can flip, we can turn our objects, and those are all transformations. But in order to be a translation, all we do is push and slide. All right, so now what we need to do is describe the translation of the segment. All right, so we're looking at the segment. So the segment we're going to look at is this PQ. All right, and we want to know how did it move to become this. So we're looking at what point P does. So to move from P to P prime, this is what we're looking at. We had to move our object. We had to move 4 units to the right. So if we look, we went 1, 2, 3, 4 points to the right, and then we went 2 units down. So we went down 1, 2. All right, so we've looked at this point P. It slid to the right and it slid down. If we look at point Q, so now we're looking at this point Q to Q prime. If it's a true translation, it has to go in the same direction and the same distance. So if we look at point Q, it went 1, 2, 3, 4 points to get to Q prime. So it went 4 units to the right, and it went down 1, 2, so 2 units down. So we know that it moves 4, so this segment, every point on that segment PQ moved 4 units right, and 2 units down. All right, so we're simply looking to see how can we move it. We're going to make right and left or up and down moves. We're not going to do anything diagonal. We have to follow kind of the coordinate plane, these XY coordinates. All right, so now we're going to look at using coordinate notation. So we want to be able to go from A, this point right here, to A prime, which is this point right here. So to get from A to A prime, we have to go 4 units up. They have it drawn here. I'm going to do my up first. So I went up 1, 2, 3, 4. Now they're level. So I moved 4 units. I'm sorry, guys. I just did it backwards. They have it in your book. They have you do the right and left. So I'm so sorry for that. We do 1, 2, 3 units to the left. And then they go 1, 2, 3, 4 units up. I apologize for that, ladies and gentlemen. I'm trying to fill in the blanks, and I should look at the answer key. You can do your up or down or your left or right first. They just did the left first. So that's because we're moving backwards. We move left 3. And we're going up, so we go up 4. So what we want to do is consider that in terms of coordinates. So because we went back 3 spaces, I'm taking x and I'm subtracting 3 units from that. Because I'm moving up, I'm adding 4 units, so that's a positive 4. So how do we describe this translation? Well, this translation is going to be described as taking your x coordinate and moving it left or negative 3 spaces. You're going to take your y coordinate and you're going to move it up. Going up on the coordinate plane is positive, so it's going to be plus 4. So this is how we describe using notation. Left is going to be a negative move. Right would be a positive move. All right? We then are going to have our up and down. So if I go up, that's positive. If I go down, that's negative. So this is kind of a nice little reminder to have in there. That when you're counting, you may only count spaces, but if you went to the left, you have to put it in your notation as a negative. All right, let's take a look at the checkpoints. Describe whether the figure in black or the figure in gray is a translation of the figure in black. So is this is my image, is the image a translation of the original? And then describe the translation using words and coordinate notation. So I want to know, did you go left or right? And then did you go up or down? And then how many spaces? And that will give you, from there, that will give you your coordinate notation. So you have to put your plus or minus there. These are going to be due now, and then we are going to check in class. Okay, I'm going to pull you up and take a look at those one-on-one tomorrow. All right, we've got one last example to take a look at. Let's take a look at that. We have to draw a translated figure. So it says to draw a triangle with vertices -2, 5 for A, 0, 7 for B, and 3, 7 for C. Then draw the image of the triangle after a translation given by. The original image is to add 2, subtract 3. So this means to go right 2 with your x and to go down 3 with your y. That's what the plus 2 and the minus 3 mean. So let's get those points plotted. Let's do that. So I need to do -2, 3, or -2, 5. And that's my A. 0, 7 is my B. And then 3, 7 is my C. So I have this. So this is A, B, and C. I'm going to change colors. So when we look at this, we're going to take that notation. X, Y becomes x plus 2, y minus 3. It means we're going to slide each point. We're going to do 2 units to the right, which is what we saw at the very beginning, and 3 units down. So I'm going to take A and do 2 units to the right. 1, 2, and then 3 units down. 1, 2, 3. So this is my A, and label it as A prime. I need to take B and move it 2 units right. 1, 2, and then move it down 3. 1, 2, 3. And here's my B. C is going to do the same thing. 1, 2 right. 1, 2, 3 down. And that becomes C prime. We connect those. And there is my triangle. So let's take a look at what this means in terms of calculating this. What you're doing is actually taking the coordinate and simply doing the math that it says there. So for A, when we have the point -2, 5, we're taking -2 and we're doing the plus 2. We're taking the 5, the y coordinate, and we're subtracting 3. So -2 plus 2 is 0. And 5 minus 3 is 2. If we do a split screen, let's take a look at what we ended up with. If I look at my point, 0, 2 is right here. That's where A prime ended up. So whether I'm physically moving that point on the coordinate plane or doing the math that's on my notation, I'm going to end up with the same point. So if we take a look at B, B prime has to be 0 plus 2, and then 7 minus 3. So B prime would equal 2, and then 7 minus 3 is 4. If I look here, B is, we trace that, it is 2, and then up 4. So there's my B. So that's the point 2, 4. If we look at C prime, I need to take 3, the x coordinate, and add 2 for the plus 2. I need to take the y coordinate and subtract 3. So I end up with the point 5, 4. And sure enough, C hits the x-axis at 5. It hits the y-axis at 4. So that is the point 5, 4. All right, so ladies and gentlemen, we're to the end of it. You have a checkpoint. You have a figure, F, G, H, J, and you want to translate it with this given notation. So you're going to move the 3 and move the 2. You got to decide left or right, and then up or down. And then you do have this quadrilateral W, X, Y, Z, and you're going to move it with this translation. So I should see a new figure, and this is for you to do now so that I can check in class with you. All right, ladies and gentlemen, enjoy translations.